And
Recording in progress.
And similar to that, another requirement that so they don't want to use access keys and secret keys whatsoever for talking to a service. They only want to use STS style access. I know we briefly touched upon this last week, but yeah, it's been on my mind throughout this week. I think might be worth bringing it up today, just a little bit. Before we get into that, I want to give a quick update on the KEP. So we've had a good amount of feedback on the KEP from cozy members itself, and I think it's in pretty good shape after the review and what updates we made to it. And I'm going to start pinging Tim. Given the shape it is in, I think it's time to do that. If anyone wants to take a last look at it, just to make sure everything looks good, that would be really helpful. And if Guy is here on the call, Guy's not here yet. He left one comment that I still haven't made an update for, and the comment was about using selectors for allowed namespaces rather than just a list of strings. So I can't fully exactly remember which way we went. Both would work. I personally prefer the selector approach because it's more in line with how rest of the things are done in Kubernetes, and also just seems more intuitive and more flexible. But I can't fully remember what we decided on for allowed namespaces. Did we decide to just have a list of namespaces that we put into this list of allowed namespaces, and if those namespaces exist, then we allow buckets to be mounted into them, or mounted is the wrong word, but attached into those pods from those namespaces, or did we say we'll use a selector, and whatever namespaces that selector selected would have access to the buckets? Which one did we finally decide on? Does anyone remember?
Can you hear me now?
Yeah.
Okay, stupid headset. I'm having issues. I thought we tried to do both because there was that use case that people kind of agreed was good. But my stance was like we want to make the easy case easy, and if it's only selectors, then like a simple list of a few names because harder than needs to be. But if there's a way to sort of allow either at the same time, then
it's like node. It's equivalent to this concept of node name and pod, and also node selector. Both exist, and then now we also have affinity. But I personally think multiple ways to do one thing is a terrible idea. But in this case, I don't know.
I agree. Multiple ways to do one thing is terrible, but like you have to make the simple case simple. If the simple case is hard, then you've made a complicated API just for some corner case that may or may not ever matter.
I see what you're saying. Yeah, if the simple case is, you need to be able to select every node by default or something like that.
Or if you just have three namespaces, you say I want to share with these three namespaces, it should be easy to express that. You shouldn't have to.
What if we said, well, you could. Is it a lot to ask if we said they have to label the namespaces and then select those namespaces in their bucket class, or is it okay? And also for the simplest use case, which is there is no restriction on namespaces. What if we said putting nothing in there means you can run it on
in general, requiring the user to do something like label a few namespaces wouldn't be a big deal. If it has RBAC implications because users aren't able to label namespaces and only admins can do that, then we'd want to look hard at the RBAC implications.
I see. So you're saying if an admin has forgotten to label a namespace and the user wants to use it, or the admin has added, let's say the admin has added the right selectors, but he hasn't gone and updated the labels in a particular namespace, the users can do nothing about it because they can't go and update namespace.
Right. That's what I'm thinking. So, I haven't thought through all the use cases to know if that's a practical problem, but that's how I look at it, is you don't want to create a situation where all of a sudden you need an admin to do something where previously you didn't.
Okay, so I see what you mean. Even in that scenario, it seems to me like selectors would be more flexible because yes, if you have a selector, then new namespaces added with that selector by default get added to the list of allowed namespaces rather than even having to manually go and put in namespace lists there. Wouldn't this actually be more empowering and less likely to require admin?
Potentially. I mean, I don't know of anything that relies on namespace labels, and I don't know how easy a user can observe their own namespace labels and what it takes to manipulate namespace labels.
I mean, the admin would have to set it themselves. I don't think users can go and do it because namespace is a cluster level resource.
Right. So I don't know. I mean, I don't have a strong feeling about it.
Right.
We just don't want to back ourselves into a position where like the really easy thing where Alice and Bob want to share a bucket is now requires an admin to get involved.
But it's like in a pod spec, if you don't put a node selector, it can go on any node. If you don't put a namespace selector, I think, and I think it's allowed from all namespaces. That empty, the default case is
But
pretty straightforward.
But the difference is with the node selector, like that's just a scheduling concern. Like there's no security implications to what node it ends up on. If my buckets are automatically shared with everyone, and I don't want them to be, that has huge security implications. Right? But by default, my bucket shouldn't be accessible to anyone but me.
I mean, what about like a? I mean, the security implication applies to node also, right? Like, what if you're using a host path volume?
There's pod security policies that control whether you're allowed to do that, and the vast majority of pods cannot use host path volumes because they are a security threat.
Right.
Right. If you can create a host path volume to /etc and you can read etc shadow and start cracking the password database, like now the Kubernetes admin has a problem. So like they don't allow that. It's just prevented. And then if you have a pod security policy that says you can create host path volumes, then you can. But the default should be secure. And then you opt into sharing or granting access or whatever through some mechanism.
I see what you're saying. So does allowed namespaces that having just the list? Okay, coming back to nodes and yeah, I see what you're saying. So you're saying it's just a scheduling concern, and you're saying with nodes there's no security issue like this. I see.
That's more just an operational question of what node is it going to run on, and that's part of the whole point of Kubernetes is to schedule stuff across nodes. But with buckets, like by default, all the buckets I create are only readable by me because anything else would be insecure. And then if I get together with Alice and say I want to share this bucket with her, I'm going to give her the name, I'm going to grant her the access somehow. I mean, we still don't know how you actually mutate this field because it's on a non-namespaced object, but I should just be able to say just me and Alice. That's all, and then that should be able to go into effect.
Yeah, I think one of the reasons it's hard to make a decision on allowed namespaces is it's actually right now the solutions we have are actually not enough or not good enough, I think. So if the simplest use case has to be made really simple. You're right. But I can see a scenario where I'm even wondering if something like a taint and toleration type of mechanism would apply here, would make more sense here, or something like a pod security policy style mechanism. Like maybe pod security policy should allow pods to access a bucket, just like host path volumes. Maybe
you're saying in lieu of the allowed namespaces list or allowed namespace list of selectors, like something entirely different to control who can see what buckets or who can access what buckets.
So the way where I'm coming from is rather than this being enforced at the bucket layer, shouldn't we actually be enforcing who gets to access buckets or not at the pod security policy layer?
I don't think so. The PSPs are about the admin making sure that users on his cluster can't elevate their privileges and take over the cluster.
Yeah, right. So pod security policy also helps you, set up or work with, say, SC Linux rules, and you can, so for instance, you can, an FS group. So you can allow a host path volume, but you can only allow it from certain directories, for instance. So the reason I bring it up that way is it is more nuanced than just, whether you allow some large feature or not.
But
So
I mean, but the whole principle behind pod security policies is like, no one should need to have host path volumes for most of the Kubernetes use cases. Every now and then you have like infrastructure type pods that are performing some role on the node, and like they need host path volumes. And so you vet those specific pods and say, yeah, I trust that the guy producing these images is not trying to hack my cluster. Therefore, I'm gonna allow these pods to run with a different pod security policy that gives them a little more access.
I see what you're saying.
Because I
You're
trust
saying,
them, right?
okay. So you're saying PSP is more of a pod security policy. PSP is more of a gating mechanism rather than kind of a selecting mechanism. You don't use PSP to say these are all the pods that are allowed to use this, but it's more like a way to say no pods that belong to this default PSP should be able to access this.
Right. And then you poke holes in the policy as needed for specific things that need access to specific other things.
Right. You definitely don't want to put selectors there. Then you're right. Okay. So, maybe not pod security policy. What about something like taints and tolerations? So if a bucket is tainted, nobody can use it unless they can tolerate it. But what's the security mechanism behind that? Can anyone tolerate a taint?
I was going to say, yeah, like the taints and tolerations, first of all, is a fairly complicated system for mortals to understand. Like when people come to Kubernetes and you explain to them taints and tolerations, their eyes glaze over. They're like, what the heck are you talking about?
Mm-hmm.
And they aren't about security at all. They're really about controlling behavior. So like the most common taint is the not ready taint, right? Like your node goes down for some reason. The node lifecycle manager controller marks it not ready with a taint. And by default, every pod tolerates that taint for exactly 300 seconds. So pods will self-evict after 5 minutes of the node they're on not being ready. And that's a good default. But you can override it and you can say, I want to self-evict after 0 seconds. So the instant it's marked not ready, I'm out. And you can have other pods that say, you know what, I'm going to wait an hour for the node to come back because, restarting my pod is really expensive. And so it lets you tune your behavior on but it's not about security. It's just about, that there's a default and you can change the time up or down to get faster or slower responsiveness to things happening in the cluster. That's really what tolerations are about in my mind.
Okay, so even that wouldn't work then. I see where you're coming from. Okay, so coming back to allowed namespaces, selectors versus just a list of allowed namespaces. I feel like with either of these approaches, it's not really a security policy. It's more of a pseudo security policy, because all you're saying is selector is actually in a sense worse than, because if you use a selector, you're saying anyone which has any namespace which has this label can suddenly access this bucket, rather than even specifically picking the namespaces. I'm just looking for a way to be more specific, or be sure that no unintended users can use this bucket, because this was one of the feedback that we got during the previous SCEP review, which where it was said allowed namespace really isn't a security mechanism. It's kind of a convenience mechanism to make kind of say that people won't use it the wrong way.
Yeah, I mean, what we want is some sort of access control list, right, where users can share with some people and not others. And the question is, who gets to make those decisions, and how are they? What granularity are they at? How are they stored, and how they are expressed? I mean, I think the reason that the KEP reviewers honed in on those the first time around is because it had, which way we go has such dramatic impact on like the API design. Like whether you need not namespaced objects or non-namespaced objects depends greatly on what exactly you want to do here. We went through the iteration where we talked about the concept of like a clustered bucket as another kind of bucket that was non-namespace that everyone could see, or a clustered bucket request, or what, I forget what we were calling it, but we were imagining having a namespace and then a non-namespaced twin, and saying that the namespace ones were not for sharing; they were to be stuck in your namespace. And if you wanted to share, maybe you needed to go to the non-namespaced version. And I remember we spent a week or two talking about that, and we kind of came down on the side of no, we didn't want to do that. We wanted to stick with our original design of having a namespaced request and a non-namespaced sort of thing that it binds to,
Right.
create a way for multiple namespaces to bind to the same one. And so I don't know.
Yeah. So that discussion came about from this whole idea of self-service, where it felt like self-service wasn't really possible because you still needed a bucket class to have been created by an admin beforehand. So but it's really not the case, because it's no different from storage classes.
Yeah. I mean, it's a one-time upfront thing to create the classes, and then from that point on, you can turn the crank as many times as you want to get buckets out.
Right.
And the question is just, if Alice is cranking out buckets and she wants to share them with Bob, how does she do that?
So if we had some kind of, can we rely on the RBAC infrastructure somehow? Can we say something like people from this namespace or users from this namespace can only use these bucket classes? Is there a way to do that other than making bucket class namespace?
I think you can lean on the quota system to say that Alice has a quota of 10 gold buckets and 0 silver buckets, and Bob has a quota of 0 gold buckets and 10 silver buckets, and therefore they effectively can't use the same bucket classes because of the quota system.
Oh, how does that work? I'm not too familiar with that. Can you explain a little bit more?
I'm trying to remember, because I am not familiar with the quota system myself, but I thought that you could specify a quota per storage class with the PVCs. So like, I know that PVCs, you can set a number of PVCs that you're allowed to have, a total GB of the PVCs you're allowed to have, and I thought that it also extended to per storage class you could have separate limits.
I see. Does anyone else know here?
I wish I had spent more time looking at the quota system to familiarize myself with it. But short of the quota system, I don't think there is a way to sort of say that Alice can't use the storage class. If it's there, everyone can see it and everyone can point to it because it's just a name.
Yeah, makes sense. Actually, so using admission controllers, it is possible though.
Well, yeah, admission controllers can do anything, right?
because you can get the name of the user, and you can also get what they're trying to access.
But that's always an overlay on top of like standard Kubernetes behavior. If you want to alter the default Kubernetes behavior by sticking an admission controller that puts your own rules on it, you can. Kubernetes doesn't play those games itself.
Can we call it bucket RBAC or something? I mean, I'm just doing a thought experiment here. I'm not suggesting we do this, but more like it might actually work. That could be our final solution that we'll probably end up with after V1 or something. But using bucket RBAC, we can kind of get the functionality, I think, that we're talking about.
But when we had this discussion before, like the thing I wanted to caution you on is like, when you have webhooks and admission controllers looking at requests, they only get to look at like individual API calls. Like I'm trying to create this object and I am B Swartz. And so like they can veto that or not veto that. But like once the object is created, then like when another controller looks at it, the fact that B Swartz created it is nowhere to be found, right? Because it's just an object in the server now. And it has to make a different decision about, can I bind this BAR to this B? And the fact that Ben created the BAR is not accessible to that other controller because
I see what you're saying.
Because it got created and now it's in the database and Kubernetes doesn't remember who did what.
Okay, so people can still guess the name and kind of just work with it.
That's my fear is yeah, like trying to rely on the emission controller is a bad model because we have a whole chain of controllers that perform these operations, and the user's only present in the initial request part of that chain, and then they disappear.
Okay. I see why namespace selector is probably, or namespace level access control is probably the best way here. Because then you can control it at the namespace level, or at that resource level, because there you're actually controlling rather than based on who made the request. It's more based on where's the request coming from. So it doesn't matter who made the request to bind a bucket access request to a bucket. If it's coming from the right namespace, we allow it. If not, we don't.
Exactly. That's my feeling, is that the namespace is always going to be available to us, and so it's a better primitive to base the security model on.
I see where you're coming from. That's actually okay. I think that makes sense. Let's see, Guy. I didn't get a chance to read everything you sent. Can you explain it?
Hey, I'm not sure if you can hear me though.
We can hear you.
Yeah, we can hear you.
Welcome.
Hey, so I just wanted to check. I remembered that there was a storage class, but I forgot how. So basically, you can specify either globally for all storage classes, the limit of how much storage or the limit of how many claims for PVs. And the same thing you can do in a per storage class limit in the quota. So you can specify, like Ben said, gold per dot, and then there's like this storage class dot storage k8s IO. Request storage means how many requests for storage you can provide. And so yeah, it's per storage.
I see. So request or storage is total capacity you can get. Some
Right.
storage requests cannot exceed this value. We were talking more from the sense of, is there a way to limit per bucket class, which all namespaces, a different way to limit from which all namespaces a bucket class can request buckets from.
So you can do that. You can certainly do that, because what you do then is you create your quota limits in a way that selects which you have selectors there as well, and then you select which to which I think to which pods eventually this. I think it selects pods, or no, it's probably selects PVCs then. But there is some selector here, scope selector it's called, and things like that, where you match things in your pods, as far as I can see. Mm-hmm. And but in the pods case, it's meant to be quota for CPU and memory, right? So it's like the different case. I'm not too sure if the same applies in storage, but I think so.
I see.
And then you can select which namespaces each quota limitation. That's yeah.
I think someone else was saying something.
Yeah, even it's different here. Even I didn't work with the source quota. So basically, you can if I recollect properly, you can define it for namespace. So basically, on this namespace for this storage class, this much quota can be set, something like that.
I see. Okay.
But
so,
I never worked with it, just from the reading and.
So this scope selector, what all can it select on? Can it select, is it PVCs or pods like you said, or can it do on, I mean, if it was just doing it on namespaces, then it's the same thing we're talking about, right? Without the quota concept itself, but
the difference is that admins set up quotas, right? We don't want admins to be doing this operation.
Namespace selector, you mean?
Right, like quota is about the admin putting a limit on an end user. Users have no reason to adjust quotas themselves, but we keep. I have the belief that users should be able to share buckets by themselves.
Yeah.
Without the admin getting involved. So that's the asymmetry that I see, is that some things are for the admin to worry about, other things are for end users to worry about.
Yep. I see where you're coming from. So actually, based on all this discussion, it seems to me like unless there's a stronger security model, like unless there's a stronger way to say only these resources can use it, and on that resource level there's a way to say like for instance, if I could say only pods with these labels can use it, and users cannot just add that label if they wanted to. If something like that existed, then that's a very strong security mechanism. But because we don't have something like that, at least not as far as I know, it seems like namespace is the best way. Either allowed namespaces or namespace selector. Again, I'm leaning towards namespace selector, but maybe we could unless does anyone have an objection to that, or does anyone have other ideas about how we should do this?
So I also agree. I don't see any pattern inside Kubernetes today for for sharing a resource like we are mentioning. So I think we have to go with, yeah.
Someone is working on a storage transfer KEP to transfer volumes and transfer snapshots from one namespace to another. For a variety of reasons, I think it's been downscoped to just transferring snapshots and not volumes. But it is based on this idea that if Alice has a PVC that she wants to share with Bob, she can take a snapshot of it and then transfer the snapshot to Bob by them both creating an object that sort of handshakes, and then the server will, or the controller will sort of renamespace the snapshot. So it's like a peer-to-peer sharing kind of a operation where they both have to turn their keys, and then the transfer occurs. And it has a lot of the similar characteristics, but it's not accepted yet. It's still a KEP being proposed for snapshot transfers.
Right, I saw this as well. But so you mean that in our case it will be transferring a bucket access request? You mean, like, well, if
I'm not saying that like the exact mechanism is something we should emulate. I'm just saying like it's another case of peer-to-peer transfer where no admin is involved. You just have a controller that is running, and then if Alice creates a certain object and Bob creates a certain object, the controller just does its thing, and boom, it's transferred.
Right, but and it does rely on these users, sorry, knowing each other, in a sense that they identify each other by a namespace or something like that.
Yeah, they have to have some external communication channel, because what you don't want is for Alice to be able to create PVCs and just send them to Bob when Bob didn't want them, right?
Right.
Like Bob has to both want it and Alice has to be willing to give it up for the transfer to occur.
Right. Basically, so if I would just frame it in what we're doing, let's say that I have a bucket access request, which it's already has, it's like already fulfilled, and there's already a bucket access object underneath, and then I somebody else wants to get that from me, and I tell him, okay, get ready for it. So he creates his bucket access request in a way that makes it ready for transfer, and then I basically do this transfer between my bucket access request to his, and that's kind of the delegation thing.
Yeah. So I kind of like that model, because that is very different than what we've been talking about so far. That would be then no one would ever have to change the non-namespaced object. You wouldn't need a policy on it. You would just need every time every time someone wanted to gain access to the bucket, that an object would be, two objects would get created, one in each namespace, that would end up referring to each other somehow to affect the grant. And then I guess the only issue I see with that makes it weaker is that after Alice gives a bucket access to Bob, there's nothing to stop Bob from giving it to Charlie, even if Alice doesn't want Charlie to have access. Like once she's given it to Bob, Bob can give it to whoever he wants. So she loses control of it at that point. But presumably, the
Not
act of
necessarily,
sharing it,
no. I mean,
the act of sharing it means she was willing to let Bob do what he wants with it.
but also not necessarily. I mean, the transfer can be user driven, but it doesn't mean that the bucket access that I created necessarily has, can then be used for anything. Like maybe
I mean,
it has
right,
like
the bucket access can be scoped to whatever level of access Alice is comfortable with. But the point is, once she hands that to Bob, she can't stop Bob from handing it to a third party. Because
well, she can't stop Bob doing that, just by copying the credentials. But maybe she can do that inside of Cozy by specifying something that will not allow another transfer. That's all.
I mean, yeah, I guess we could come up with more rules, but like the simplest flavor of this I kind of like is that the originator of the bucket has to create something that refers to the sharer has to create something that refers to the sharee, and then a transfer can occur. And then no one ever needs to mutate the non-namespaced object. I do think we'll end up having to create a new kind of object. Like for the snapshot transfer, they're considering some explicit snapshot transfer CRD object that like exists for this purpose alone. So like we might end up having to create a specific CRD for that. I don't know if we can just change the existing bucket request object to completely handle this use case, but maybe we could think about it. But the big benefit is, yeah, if no one ever needs to change the non-namespace object, then with regular RBAC, anyone who wants to do this can do this. The admin is completely out of the way, and the only burden is that Alice has to be around to grant new accesses to anyone who wants to use it. So every time a new user shows up that needs to get access to the bucket, someone has to do something in Alice's namespace to make that happen.
Which makes sense as well.
I guess. I mean, you could imagine Alice taking the stance that like, I just want to share this with anyone who wants it, and I want to be, and don't bother me again. And then from that point on, anyone should be able to just grab it. Like that would
so
be
that's the selector model, right? That's the kind of selector.
Sure. Yeah. Okay. Yeah. But if it's selector in the form of a namespace object in Alice's namespace that basically is like a bucket access grant selector that basically is a wild card to say, you know what, accept all requests. Anyone who wants it gets it. Then
right, just like select anything, no labels or something. Yeah.
Then I could see that being reasonable. And if we had that scheme, then we could completely get rid of the allowed namespaces, because no one would ever have to check that. All you'd have to check would be the existence of these other objects. So, and allowed namespaces has been a thorn in our side from the beginning.
Yeah.
So.
Hey, I missed a few parts of this. Can you explain the solution again, please?
Okay. So yeah, let me. Unless you want to, Guy.
No. Go ahead. I think
okay.
You got it.
All right. Well. So imagine the regular self-service case that we have so far.
Mm-hmm.
Except buckets don't have an allowed namespace on it. When Alice creates a bucket request and gets a bucket, and then she creates a bucket access request and she has access to her bucket, she can use it exactly like it is now. When she wants to share it with Bob, what she does is she creates a new BAR in her own namespace that she's going to give to Bob.
Mm-hmm.
And so she creates it in such a way that like it's initially created in her namespace and only usable by her, but it has some extra piece of data on it that says like, I'm willing to give this to Bob. And then Bob also creates a BAR in his namespace that points back to the one Alice just created, and they have to exchange some information out of band, like maybe the name of the BA, that it got bound to or something. And then as long as both of these objects exist, one in Bob's namespace pointing to Alice's, one in Alice's namespace pointing to Bob's, the controller will just switch the access over so that Bob now has the BA that Alice used to have. Basically, it'll take the BA and rebind it to the one in the other namespace. And then Alice can get rid of her BAR because Bob now has it. And Bob now has his own BAR that points to the old BA. And now Bob can just access the bucket as, directly through the BA that Alice created and then transferred to him. Does that make sense?
I don't think it solves the problem though, because how many BAs? So can okay, maybe it is possible, but let's say the BAR that Alice creates to share the bucket, can it be bound to any namespace, or is it for a specific other namespace? I'm just talking.
So it would, when she creates it initially, it's only going to be in her namespace, because if no one in any other namespace claims it, it's not going to go anywhere. It's just going to sit there, right? You don't want to give Alice the power to push objects into other people's namespaces. So all she can do is create the BAR for herself, but flag it for transfer to a specific place.
Yeah.
So can I play it out a little bit, like a little bit out of the box here? So what if this BAR that Alice creates? So one way that you just presented, like Ben right now, means I want to hand off this access to someone in particular, Bob, right? I'm referencing specifically, it's going to be Bob in this namespace, and like something very strict. Perhaps the other method might be, this is a BAR that I hand off to others, to Bob and others, right? So Bob 2, Bob 3, and then whenever a bucket access gets transferred, this BAR sticks there in Alice's namespace and allocates a new one ready to be transferred as well, right? Something like in the sense of, this is a resource, this is a request for bucket access that I can transfer to these and this. So it can be one-to-one, saying like a transfer request, like that was I think for snapshots. And then the other option means it's just a tombstone here saying, I will keep on transferring it to anybody who I allow. Basically, if I say this is allowed to this and that selectors, from a user perspective though, right? Not an admin perspective. So, like I can select other namespaces by name or selector like that, and say each one of these can get bucket access from me, and I just allocate a new one or something like that.
The reason I like the one-to-one is that, like, it gives Alice fine-grained control over exactly what level of access she's creating and giving to Bob. And then if she wants to give Charlie a different level of access, she can create a different BAR with a different BAC,
Right.
and then transfer that one to Charlie. And so
Right.
she's in the driver's seat every time one of these transfers happens. She knows who got it and what level of access was given.
I'm sure that we can always fall back to the one-to-one, even if we support more than one. But the option of more than one just means that Alice is not needed every time there. It's like a policy that Alice publishes saying, this is what I want to provide to my peer users here, and whenever they are ready, I'm ready to provide it. Right?
Yeah. No, there is value to that too. Just to have a wide open thing. I guess the what matters is mechanically, there's an object in Alice's namespace. There's an object in the other person's namespace. They both and Alice's gets bound to a specific BA before the transfer happens. And then the question is, do we actually take that BA and rebind it to the other person's BAR so that Alice loses it, or do we copy it so that they get, because the difference is every time you create a BA, you have to go all the way down to the driver and call grant access, get a new access key, get a new secret, and put it on the BA object, right? So I was imagining that Alice would create the BAR, go all
And
the way down the
hand
chain,
it off, right?
get a grant, and then hand it
move
off.
Right.
If you do some sort of an automated thing, then now other people are basically, their actions are causing the cozy driver to get implemented and the grant access to get called and the access key to get generated and the secret and whatnot,
Right.
which feels a little, I don't know, just it feels different. It could work. I don't see any obvious problems, but I like the idea that Alice causes it to occur through her actions, and then she hands it off to other users to cause the sharing to occur. Before we get to the end of the meeting, Sid, you would wanted to talk about STS style access.
Mhm.
And I, as you know, am against it. I want to hear the case again.
Well, I just want to provide a solution rather than just go for STS. So we're working with a customer. I can't take the name, but just say that it's a large bank, and they have these security control mechanisms that are site wide. An example of that is, you're not allowed to mount any non-standard environment variables. So that no other process can just sniff out environment variables and read credentials or some other sensitive information. Similar to that, they also have this other requirement that nowhere in your system should you use access keys and secret keys. Some other form of authentication needs to be used, and this customer of ours uses STS.
Right. I mean,
Mhm.
we all know, corporate security teams sending down edicts of this flavor for various reasons, and we know why they do it. And so it doesn't surprise. I guess what my question would be is like, is this the kind of user that actually needs cozy, or are they happy doing what they're already doing? Like,
I would think this is the kind of customer that'll need cozy the most, because so they come from this world of CSI, and the first question they ask is, how do I do in our case Minayo, right? Like how do I mount Minayo into a pod automatically? And then we go over the whole thing about how object storage is not supposed to be consumed over POSIX, and it's better to use the API directly and all that. And then that's how we kind of touch upon cozy and everything at that point. But the reason I'm bringing this up is I would think someone like, I mean, I think it's too early to architect for it, but since we're talking about since we're just designing the system now, I think it's good to keep in mind that such a requirement might come up in the future, where access mechanisms, because there's two pieces of information we share with the pod. One is the endpoint itself and what you're accessing. Another is how the credentials to access it, and this credential mechanism wise, it is highly likely that we might have to support some other mechanism other than access keys and secret keys. It need not be STS.
I mean, so I get frustrated, I guess, with some of these security people that it feels like they're doing cargo cult security, where they see a vulnerability and they say, well, we're going to change our process to never do X and therefore we'll be secure, rather than thinking about what you're actually doing. So like, if the concern is that like using access keys and secret keys is dangerous because of someone can read something somewhere, you have to think about in the context of cozy, who can see those things, and if you were to use STS or some other form of authentication, like have you shrunk the circle of who can see the sensitive information? My suspicion is the answer is no. That whether you use access keys and secret keys with cozy plumbed through by cozy and everything, or use STS, the class of attacks that will allow you to actually compromise something are the same in both cases. And so I'm not convinced that there's a practical gain. I mean, there are obviously bad ways to use access keys and secret keys that would expose your data to compromise. I don't know.
But I guess that could also apply. I'm supporting your case. That could also apply to STS tokens.
Right. I'm saying
Right.
that like the kind of users who can steal your information with the security scheme we proposed can also steal your STS tokens and everything that comes out of those. So it's like you haven't prevented anything by upgrading your security. So I want to be really, I really want to understand like what are they actually worried about?
No, it's like you said, it's an umbrella control mechanism, and you just have
Yeah.
to kind of see as a vendor, it's harder to convince them. But as a community, as Kubernetes people, we can set that standard, and that's fine.
Yeah, I think that the way that we've proposed using access keys and secret keys and storing them in Kubernetes secrets and plumbing them into the pod means that they're pretty safe. Like unless someone either compromises the etcd behind Kubernetes or compromises a node on which one of these workloads is running, like they're not going to be able to get these keys. And if they do either of those two things, the STS scheme isn't going to help you. So, you know,
Right. Yeah, and you know, we provide the ability for them to revoke credentials already. So I think yeah, I think it was just worth discussing once.
okay.
Rather than
And unfortunately, I'm not an expert on exactly what STS does internally and exactly how easy it is for everyone to support it. So like, I can't speak to whether the mechanism buys you anything.
So it's like OAuth. It's not very different from OAuth, but generally they integrate with Active Directory or LDAP instead of OAuth. So you know they already have some kind of user credential mechanism, whatever that is. So you know a user would be able to. So say they have Kubeflow running and Kubeflow accesses object storage. So whoever starts the workload on the Kubeflow side, their access and secret would be tied to, or their Active Directory username and password would be tied to an IAM role in the object storage backend. And if that user has access to a particular bucket, they get access to the bucket. But the way Kubeflow gets, takes the Active Directory credentials and gets access to S3 is using the STS token. So it talks to the S3 backend and provides these. Well, it talks to the Active Directory backend and gets a token back from there saying, hey. This is an authenticated user. Here's the token for that user, and then that token is given to the S3 backend, and that gives back your STS token that can be used back and forth. It's exactly like the OAuth mechanism, but with it can be done with OAuth too. It's
right,
actually
but where are the decisions enforced on who gets access to what?
So the IAM policy is given by the admin. So,
right, but like the whole point of Cozy is that the guy who created the bucket sets the policy on who gets to access it, right? Like it's the whole policy, the whole idea is the admin isn't involved, that the user decides. It's my bucket. I can share it with Bob if I want to or not. And no one gets to come in above me and tell me who my bucket is shared with or not shared with. It feels like they want something other than Cozy. It feels like they want integration with that authentication scheme where just maybe some
we have a
magic
solution
that
for them.
helps their buckets.
So the thing is, we have a solution for them. I'm bringing this up from the context of is that something we'll ever need to support? It's more of a question rather than a requirement. So they're happy that they're not using Cozy now, and they're able to work around with all this. But the question is that use case something that is even relevant to us?
I think that Cozy is never going to have anything to do with like Active Directory or these external, IAM systems. It's the security model for Cozy is built into Cozy, right? You create a bucket in Cozy, you grant access in Cozy, and Cozy is the end of the story when you ask the question of who's allowed to access the bucket. That's the model we've gone with so far, is that Cozy is the decider. Cozy is the source of truth on all of these questions. If you want to add in external sources of truth, like you need a different API than the one we've designed, right?
Fair enough.
Like I hope that people, I hope that Cozy gets shippable and people start using it and think that, oh, this is a better way than what I'm currently doing, right? What
I
I'm
think
currently
that's
doing is
totally possible. Mm-hmm.
yeah, and then they switch over and they're like, why was I doing what I was doing before? That was really hard, and Cozy's really easy. If we've done our jobs right, that's where we end up.
Yeah, I mean, if we don't, we learn from it and fix it. So, okay, so I think that's convincing. I think that's a good enough answer. Yeah, actually, it doesn't even make sense because we're not getting into that whole life cycle whatsoever. Yeah, we're not getting into this life cycle of someone manually setting these access policies. We're working at the namespace level.
And I think we should emphasize that, like, our goal is not to take over all bucket or object storage forever and all time, right? It's a very specific way of managing buckets and using them in Kubernetes that should be useful, but like the other ways of doing it will remain valid after Cozy exists. Just like the same is true for volumes, right? There's plenty of ways to consume storage that have nothing to do with Kubernetes. And you can take volumes created in Kubernetes and use them outside of Kubernetes and vice versa. The same will end up being true of these buckets. But within our world of Cozy and the buckets that we create and we control, we should have ultimate control over what happens to those buckets.
But
Yep.
one thing that STS brings to the table is the ability to separate between the long-term credentials and the kind of short-term, like Kerberos and all. Regardless of the policy of like access control, who can access what. I'm not sure what's more valuable in the use case that you mentioned, Sid, but both of them are there in some way or another.
Yeah, you're talking about the desire for secret rotation, even if who gets access doesn't change over time, that the secret they use does change over time.
Right. We talked about it quite a lot.
Yes.
I mean,
that's a desirable feature that we don't cover in our current design. That's true.
No, the main reason is we can't enforce the client to rotate it. The client has to initiate the rotation. We can give the infrastructure for it, but we can't force the client to rotate.
Well, we can bounce the pod. That's what we can do.
Yeah, that's what we can do. But that's
you're right. You're right. It's
yeah. Okay, so one last thing, I'll go update the cap. Then I'm gonna change from allowed namespace being a list to a selector. I prefer that. I think based on today's discussion, we kind of like both work, and we have an alternate solution, which might.
Yeah. I was gonna say, if we want to pursue this other way of doing bucket access transfers between namespaces, we could get rid of allowed namespaces altogether and just pursue the new scheme. And I actually like that other way. It feels less nasty.
How about this? How about we sit on it for a week?
Okay.
Yeah, let's discuss again on next Thursday, and yeah, we'll go from there. Hey, there's another thing that I was thinking about bringing up. I completely forgot actually. But yeah, if I remember it, we'll bring it back up next week. If it's important enough, we'll come back. All right, so we'll continue this discussion next Thursday. Please take a second to review the KEP. I think it's in good shape. I'm going to start pinging Tim about this. If someone wants to take a look and make sure everything looks good, I would really appreciate that. That's all from me.
All right.
Thank you so much. Bye.
Bye-bye.